Welcome to Introducing Unreal's TArray. So in this video, I want to tell you that a TArray is Unreal's go-to container class. It's a great class for grouping together things, many elements of the same type. So in our case, that's going to be actors that are on the pressure plate in the game. So over here in this trigger volume, we're going to be able to put tables, chairs, and even ourselves. And we're going to use a TArray to store them. So we're also going to give our default pawn an eye height and a mass. And we'll be making our pressure plate based on total mass. So what that means is our pawn is actually going to be on the ground. If we move off the ground, we'll land back at the ground and we can't duck down anymore. So we're a bit more human-like as we move around the room. And we'll have a mass, as will the table and chair, which will all be ready to trigger that plate. We won't quite get to that point in this video, but see you in a moment. So let's have a little recap as to how this was working. Remember that our doors both have an open door component on them, and that open door component used to have a publicly exposed actor that opens, but in the code we changed that a little bit, so we still have this actor pointer actor that opens, but then what we did in the constructor is we just went and found the pawn. So right now, the only thing that will open these doors is the pawn itself. Well, we're going to change this around to be based on mass. So firstly, let's give our character controller a little bit of mass. How do we do that? Well, it's not a character controller, it's a pawn. Go to the default pawn blueprint, and it's relatively simple, actually. It already has a few things that we can change. The base eye height, I'm going to set that to say 60. Let's see the effect that has. So the base eye height, by the way, is in the Details tab of the default pawn blueprint under the Camera section. So if I play now, then I get an eye height, but I can still kind of float. And the reason I can float is because there's no physics. So let's go back to the default pawn, and let's have a little look what else we can change. Well, we have a collision component. So go to the collision component. Let's simulate physics. I'm going to make the guy roughly my weight, 70 kilos. We're also going to make sure that the simulation generates hits and that the collision generates overlap events. So to recap, I've gone to the default pawn blueprint, selected the collision component. I'm simulating physics, giving it a mass of a reasonable mass, and then ticking these two boxes. Simulation generates, what does it say? Hit events, I think. Yep, hit events, and generate overlap events as well. All right, now the simulation generates hit events, will allow it to do physics collisions with things, so we collide with the walls. We were already doing that. But generating overlap events is going to become important in a bit because we want the trigger volume to notice we're in it. The only other thing I've changed about this is the eye height over on the default pawn itself. So if we do that, look what happens when we use the default pawn. We can now kind of run around. We can jump by just going up, but we can run around and we're stuck to the floor, which is much better. Okay, so now what we want this trigger volume to do is notice when we're in it, or when the table's in it, which it doesn't, or when the chair's in it. And we're going to organize it so that we need to put both the table and the chair in order to actually open the doors. So that's the background as to what we're doing. I've made those changes to the default pawn. I'm going to now go into my code, and on opendoor.h, I don't need an actor that opens, so let's get rid of it. And save, which will of course immediately break opendoor.cpp because actor that opens here in the constructor, we can't set it, so let's get rid of it in the constructor. So no more actor that opens anywhere in our code. Do we have it anywhere else? Well, we could always do a search, of course. Actor that opens in the current file. Have a look. There it is, and that's exactly where our red error is because it's trying to do something with actor that opens. Well, all this code, actually, basically all of this code, not the open door code, but this bit about when we're opening the door here needs to change. So what we're going to do is, yes, we're going to poll the trigger volume, but it's not if the actor opens in the volume, it is this. It's if something like get total mass of actors on plate. Let's just imagine we've got a method called get total mass of actors on plate is greater than some threshold, which we really ought to make editable in the inspector. So trigger mass, or for now, let's hard code it. Let's say 50 kilograms, 50.f like that. Now, if you hard code something, you could make into a parameter. If you just want to focus on what you're doing, you could always put yourself a to-do to change that later into something that's parameterized, because we just want to focus. If the total mass on the plate is greater than 50, Then we open the door and everything else is the same, right? the question is, how do we deal with the get total mass on plate? Well, let's go write that method now. That's the whole point of this video. The reason I'm doing it outside of this method, outside of tick, is because it keeps tick nice and small. And I can get rid of that comment because it's gone out of sync. Polling the trigger volume, yeah, we can leave that. Check if it's time to close the door. Yeah, that's all good. Okay, so here we go. What is get total mass of actors on plate going to be? It's going to be a float coming back because we don't know that they add up to a whole number. And then it's going to be uGrabber, which is the class, syntactic noise of C++, and then there it is. Now let's go ahead and define it, and also we need to create a declaration. So I can quick actions, create declaration, and it's failed, has it? Well, it's going to parse a load of files. You know, I can't be bothered to wait for that, so I'm going to do it manually, and that's helpful for you Xcode guys anyway. I tend to put all my values up the top, and then the actual methods lower down. We don't need the name of the class, so this is all very standard stuff by now. Get total mass of actors on plate. You know, that is so, I think I will put a comment, but it's just for a clarifying. Returns total mass in kilograms. You see, that and the name of the method tell you precisely what it does. Float, of course, doesn't have a capital F, so neither does it over here. So, okay, we're good to go. We have the method here that is kind of nearly what we want, right? I'm going to save my header file, save this. Right, why don't we for now just do a test? Why don't we just return 60 F? So we're just going to return 60 kilos and just run the game and see what happens. Just make sure that the code we just wrote actually works. So at 60 kilos with a threshold, what's our threshold of 50, the door should just open and stay open. Let's see if that's what happens. Compile failed, so I've made a boo-boo somewhere. Line 55 and 57 of the CPP. So, look at me. I've been so used to writing code in the uGrabber class that, of course, I forgot that I'm in uOpenDoor. Okay, so that's what it is. And I need a decimal place in there. Great. Let's go back and try again. Compile. So the mass is 60 that method's reporting. So the moment we play, the doors should open. They do. And then if we return a mass of, say, 40, then the doors should not open when we play. You see what I'm doing here? I'm breaking the problem down and making sure I'm as close as possible to running code all the time. And the doors don't open. Awesome. So it looks like the general structure works. That's good news. Now we need to actually get the total mass of actors on plate. So we're going to need a temporary variable. It's going to be something like float total mass equals, let's initialize it, nothing. Great, and at the end we're going to return total mass. No point in doing that in pseudocode. So then what are we going to do? So firstly we're going to find all the overlapping actors, and then we're going to iterate through them, adding their masses. You can stay on this level of abstraction, that's absolutely fine. Great, so then how do we find all the overlapping actors? Well, what do we have? What do we have available? Where do we even start? Let's take a zoom out. We're on what? We're on open door. We need the pressure plate, right? So what have we got? We've got a pointer to a trigger volume. We've got a pointer to the pressure plate. So let's start with the pressure plate. Now what is this? We just said it's a pointer, so it's an arrow operator. Now if we go get overlapping actors, let's look at the signature of this method. TArray of type actor pointer reference to overlapping actors. Now the fact this is a reference to overlapping actors coming in here tells me that it's an out parameter. And this other parameter is actually optional. Now how would you find out that the second parameter is optional? You would go to Google and Google for get overlapping actors. Let's do that. And let's just see what they've got to say in their documentation about this. And here, optional, class filter is optional. Okay, and then there's the signature of the other bit. So let's just talk about what this TArray thing is here. This is an out parameter, so we're going to need to have ourselves a TArray of actor pointers. Okay, but you use these type of brackets. Pointers. So what you're doing there is say, give me an array. A TArray is, as I mentioned in the intro, is a very useful data structure. Give me a TArray of A actor pointers. All right, that's what that's saying. And let's call it overlapping what am I doing? Lapping, there you go. Actors. And let's not bother to initialize it because we're immediately going to initialize it on the next line. So TArray of actor pointers. Give me a collection of actors, of pointers to actors called overlapping actors. And then this is actually an out parameter, isn't it? Now, we haven't done hash define out. Later, we'll talk about how to make a hash define that goes across all of our project. But for now, let's just rehash define out. Remember, this does nothing. This is a macro that says replace out with nothing. Okay, it literally does nothing, but it allows us to mark this overlapping actors as an out parameter. So it just remains to say, remember that this is an out parameter pattern here. So we declare something which then gets passed into this method. And then by here, after this method call, overlapping actors should contain an array of actor pointers. And we'll find out whether it does in the next video when we actually iterate through them, adding their masses per the comment. All right, so your challenge for this video is right at the end this time, and it's to read about TArray. I want you to skim read the TArray documentation, the link's coming up. Look out for the range-based for loop in there. There's a lot of stuff, so please don't go through it with a fine-tooth comb. It'll drive you nuts. I just want you to have a quick look through, specifically looking for where they show you examples of a for loop that is able to iterate through this array. And even more in particular, the pattern that uses a colon, for something, colon something like that. So have a look and see if you can find that syntax. It's going to help you in the next video. And there are your docs to the TArray. Remember that you can click that. One of the easiest ways is to just either go to the Google Doc, which is linked from the first lecture of this section, or just to go and get the PDF from the first lecture of this section. And that's not quite as up to date as the Google Docs. They always bang up to date. Or just do a quick Google search for TArray Unreal. That might be your quickest. Okay, see you soon. If you're expecting me to come back, then not this time. It's going to be in the next video that we'll go and use this. So see you in the next video.